Welcome to my channel, everybody. Today this is the discussion about the plane of three-dimensional space. Okay. Now we have to introduce some theory about the plane here. And the most general equation of the first degree of 3D in three-dimensional plane is that is ax plus by plus cz plus d is equal to 0. This is the general equation. The most general equation of the of the first degree. Okay, that is ax plus by plus cz plus d is equal to 0. And students, see here a, b, c, that this coefficient are called the direction ratio of the normal to the plane actually. And see here, if this is your plane is this, then what is the coefficient of x, y, z are called, a, b, c are called the direction ratio of the normal to this plane. If this is the most of the normal are there, all the normal are parallel to this each of the normals. So all the normals that there are a comma b comma c, the multiply the number of x, y, z, that is a, b, c, this coefficient are called the dr. So a comma b comma c are called dr of the normal to the plane. Okay, so ABC are called the dr of the normal to the plane. Now we have to introduce another point. This is to if the plane passing through x1, y1, z1, then you can write first of all this ax by plus cz plus d is equal to 0. Okay, and when this point not satisfy this equation, then we can write here ax1 by1 plus cz1 plus d equal to 0. And now we subtracting these two equations, then we get here a into x minus x1, so b into y minus y1, so c into z minus z1. Okay, this is another formation of a plane throwing the point x1, y1 and z1 is that. Okay, is this. And now the normal form of the plane. Third is the normal form of the plane is mx ny lx, sorry, first lx my plus nz is equal to p. This is called the normal form. Actually this is called the direction quotient. So L, M, N are called here a DC of the normal to the plane, and P is called the perpendicular distance from origin to the plane. Okay, so now I want to convert this equation from that. Okay, see here, this is ax plus by plus cz, and d are transferred to the right hand side, and divide by the square root of the coefficient of sum of the square root of the coefficient of a square, b square, c square. Okay, a, b, c. Okay, now ax by squaring the coefficient of a square, b square, c square, and adding them and divide square root of that when divided by this then we get the normal from here. So b by root over of a square plus b square plus c square, and this is here y, and c by root over of a square plus b square plus c square, and this is d by and root over of that. So therefore, so L is equal to a by root over of a square plus b square plus c square, b is equal to root over of this is Ln, m equal to b by root over of a square plus b square plus c square. Okay, and n is equal to c by root over of a square plus b square plus c square, and p is equal to the perpendicular distance from that. Okay, this is there. This is root over a square plus b square plus c square actual. Okay, so this is the normal from our plane. Now intercept form. Number 4 is intercept form of a plane is here. This is x by alpha, y by beta, z by gamma is equal to 1. Actually, this is the x-axis, this is here y-axis, and this is your z-axis. So this form is called the intercept form, and it is an intersect at the x-axis at A, and y-axis at B, and z-axis at C. If the coordinate be here alpha comma 0 0, and this is 0 comma beta comma 0. Okay, this is 0 comma 0 and gamma. Then we got this equation. Okay, this is called the intercept form. Now, number 5. If the two planes are given, then what is the angle between them? You know, the angle between the two lines are actually with if theta, then cos theta is equal to a1 b1 plus c1 by over under root of a square plus b square plus c square and into root over of a1 square plus b1 square plus c1 square actually. Okay, now see if the plane here if the equation of two planes are ax by cz plus d is equal to 0 and a1x b1y c1z plus d1 equal to 0, then theta be angle, then cos theta, then cos theta is equal to actually, why I want to learn this point, be careful student, a1 b1 c1 by root over this a square plus b square plus c square and a1 square b1 square plus c1 square. Okay, so this is the angle between two planes. If actually a b c a1 b1 c1 are the direction ratios, the normal to the given plane. So but what is the angle between the two planes here is if the two planes be here like that. Okay, actually like that, then normal, this is normal, this is normal. If this angle theta, then it would be our theta also. Okay, so you can write easily cos theta is equal to a1 plus b1 plus c1 by over this. Okay, this is the most general formation of the 5 points for forming a plane in 3D. So learn these points carefully. Okay, and now we want to discuss about the 5 points, 5 problems of the plane here. See carefully. Now first point is given that find the equation of the plane which passing through the 2 points, that is 3 1 1 and 1 minus 2 3, and parallel to the coordinate axis. Okay, and now let us assume a plane through 3 1 1 is that the equation of the plane through 3 1 1, then this is a into x minus 3 b into y minus 1 c into z minus 1 equal to 0. Okay, when this plane passing through again 1 minus 2 3, again passing through 1 comma minus 2 comma 3, then a into 1 minus 3 b into minus 2 minus 1 and c into this is 3 minus 1 equal to 0. So this is actually minus twice a minus 3b, okay, and 2c equal to 0. This is 1 and this is 2, okay. And parallel to the coordinate axis, okay, when the plane is parallel to the coordinate axis, x-axis, okay, when our required plane is parallel to x-axis, then the required plane is perpendicular to, then the required plane normal to the then the normal to the required plane is perpendicular to the x-axis. Now dr of x-axis are 1, 0 and 0. So now we can write, so we can write a into 1, b into 0, c into 0 equal to 0. This is 3. Eliminating a comma b comma c from 1, 2 and 3, then we get the equation of the required plane is, that is x minus 3, y minus 1, z minus 1, okay, and this is your minus 2, minus 3, 2, and 1, 0, 0 equal to 0, and that is x minus 3, this is 0, this is 0. Actually we have to take a if you take this, okay, this is 0 here, again y minus 1, you have taken this and this is 0 and this is, okay, z minus 1, I have taken this is 0 and minus plus 3 actually equal to 0. Okay, this is here minus 2y minus 2, this is 3z minus 3 equal to 0, this is 2y plus 3z equal to 5, 2y plus 3z equal to 5. Okay, so this is for the solution of question number 1 here, so say carefully. And now second, actually this is the most important point, that will be want to note that where the plane is perpendicular or parallel, okay, and that logic would be one of the main point here, okay. And now find the equation of the plane which is passing through the point is this, passing through the point is this here. Number 2. Say find the equation of the plane which is passing through that. The required equation of the plane through, this is 2 comma 1 comma minus 1, is a into x minus 2, b into y minus 1, c into z plus 1 equal to 0. And this is 1. So 1 is perpendicular to this. Orthogonal means perpendicular. Your record plane is perpendicular to this and this. And so 1 is perpendicular to x minus y plus z equal to 1, and 3x plus 4y minus 3z equal to, sorry, this is 2z equal to 0. Okay. Now dr of the normal to 1 are a comma b comma c. Again dr of the normal to 2, this is 2 and this is 3, are here 1 minus 1 1, and dr the normal to 3 are 3 4 and minus 2. As 1 is perpendicular to 1 and 2, so as 1 is perpendicular to 2 and 3, then the normal of 1 is also perpendicular to the normal of 2 and 3. Then we can write that is 1 dot 1, b dot 1 and c dot 1 equal to 0 minus, okay, 3 dot a plus 4 dot b plus this is minus 2 dot c equal to 0. So this is here 1, this is 2 and this is 3. Eliminating a comma b comma c from 1, 2 and 3. Then we got the answer here. Only the coefficient we can write here in the determinant: x minus 2, y minus 1, z plus 1. And the coefficient of ABC here is 1, minus 1, 1. And this is 3, 4 and minus 2 is equal to 0. And that is, if we simplify this equation, then we got the answer which I want to find the equation of the plane. So this is your answer actually. Okay, just explain this. Now question number 3. Now we want to solve the question number 3 here. So same problem, just we note that the perpendicular are parallel. This is the main point actually. A1, B, B1, C, C1 equal to 0. Actually, when the two angle of the two lines are 90 degrees, then we can write easily A1, B, B1, C, C1 equal to 0. Okay, so that point is the most important point here. And now, just third. See, find the equation of the plane passing through this and this. So, just I want to mention the technique, just writing skill as follow the previous 1 and 2 problem. Okay, so now passing through this point, so this is the equation of the required plane. We have a into x minus 1, b into y minus 1, c into z minus 2 equal to 0. Again passing through the point here is 2, 4 and 3. This is 2, 4 and 3, 3. Then a into 2 minus 1, b into 4 minus 1, c into 3 minus 2 is equal to 0. Okay, so you can write here a, 3b and c equal to 0. This is 1 and this is 2. And 1 is perpendicular to the plane x minus 3y plus 7z plus 5 equal to 0. So therefore the normal of 1 is perpendicular to the is perpendicular with the normal of 3. Then and that is a into 1, this is 3 into b and 7 into c, actually 0. Okay, so this is the vital point. So now eliminating a, b, c, then we can therefore the recurrent, therefore the equation of the plane is just eliminating u, a, b, c, x minus 1, y minus 1, z minus 2, and the coefficient here is this equation 1, 3, 1, and the other we have 1, minus 3 and 7 equal to 0. And simplify this equation, then you got the required answer. Okay, so this is the third problem. Now we have to solve the fourth problem. Just fourth problem. Find the equation of the plane passing through the point this. Okay, let us assume the equation of the plane we have x minus 2 plus b into to the point 2, 2 minus 1. First you mention this point, then after putting the point other 2. Okay, that is y minus 2 and c into z plus 1 equal to 0. Again, this plane passing through the points that is 3, 4, 2 and 7, 0, 6. Then we can write here when 3, 4, 2 passing through the 3, 4, 2, we put here 3, 4 and 2 here. So this is 3 minus 2, b into 4 minus 2, c into this is 2 plus 1 equal to 0, and that is a plus 2b plus 3c equal to 0. This is 1 and this is 2, and again 7 and 0, 6 actually. So a into 7 minus 2, b into 0 minus 2, c into that is 6 plus 1 equal to 0. This is 5a, this is 2b and 7c equal to 0. One, 2 and 3. Then x minus 2, y minus 2, this is z plus 1, and is that 1 coefficient only, 2 and 3. See the technique carefully, how can we follow this problem here. Okay, so this is the equation of the plane, and we expand this detail method. We got the answer here. And now for the question number 5 here, carefully. So very interesting question these all are. So again 5 also very important question. See, perpendicular PL, PM, PN are drawn from the point that is P, that is A, comma B, comma C, to the coordinate plane, and so that the equation of the plane we have x by a, y by b, z by c is equal to 2 here. Okay, now see the drawing here. This is y-axis, this is x-axis, and this is y-axis. This is your x-axis, okay, and this is y-axis, and this is a z-axis. See, this is the point P, A, comma B, comma C on the open space. Okay, now on the XZ plane. It is on the open place. Okay, now that is we have to draw the PM and PN to the coordinate axis. So now we want to draw this is PL to the x-axis. Okay, this is PL. Now to the only this is x-axis. No. This is the coordinate plane. Okay, this is the coordinate plane. So that's why you draw a normal to the coordinate plane. Okay, now this is PL PM. This is PM, and on the XZ plane, this is LMN. Okay, now added this. Now we have to find the equation LMN. Okay, this is your. We have to find the equation of that. When this plane element and the coordinate of the n, and see this is touched to the plane XZ plane, so that's why y be 0 here. So a comma 0 c, and this is L xy plane, so a comma b comma 0, and on the yz plane, so yx is 0 here, 0 comma b comma c. Now we have to find the through these 3 points, this. Okay, and then now the equation of the plane through this is L a comma b comma c. A comma b comma 0 is this is a into, so we have to use here as a PQR. Okay, p into x minus a. This is q into y minus b, and this is r into z minus 0 equal to 0. When this plane passing through this point a comma 0 c, then a comma 0 c, so this is p into a minus a, q into 0 minus b, r into c minus 0 equal to 0. Again passing through that is here 0 comma bc, then p into 0 minus a, q into b minus b, r into c minus 0 equal to 0. So this is 1, this is 2, this is 3. So P, Q, R from 1, 2 and 3. Then that is their x minus a, y minus b, z, and the coefficient here is 0. And this is their minus b, this is their c, and coefficient here is minus a. This is 0 and c equal to 0. That is here x minus a, and this into this, so this is minus bc, y minus b, this is 0 plus ac, and z into 0 minus ab equal to 0. Okay, now that is minus xbc abc minus yac abc minus abcz equal to 0, dividing by now xbc yac ABC ABZ. That is equal to twice ABC. Dividing by ABC on both sides, then we get here x by A, y by B, z by C is equal to 2. And this is your answer for the question number 5. See carefully, very interesting question here. Now proceed to the 6 number question. Very interesting question these are. Okay, see. So see here, a plane cut the axis ABC. Cut the axis ABC and the center of the triangle of ABC here, A, B, C here. Then the equation of the plane is this. Okay, see, a plane cut the axis. This is x axis, this is y axis, and this is z axis. Okay, a plane cut the axis ABC. A, B, and C. So let us assume this is alpha, 0, 0. This is here 0, beta, 0, and this is 0, 0, gamma. Therefore, the equation of the required plane x by alpha, y by beta, z by gamma is equal to 1. Now, the centroid of ABC is alpha by 3, beta by 3, gamma by 3, and that is equal to given by the statement here A, B, C. So you can easily find that is alpha is equal to 3A, beta is equal to 3B, and gamma equal to 3C. Therefore, the equation of the required plane is x by alpha 3A, y by 3B, z by 3C is equal to 1. So x by A, y by B, z by C is equal to 3. Okay, this is your answer C. I think all of you are better understood, and this is the most important 6th problem, and for for the ICC and CBSC, and also ICC means sorry, and this is ISC and the CBSC exam, and also the Bengal exam, that is HS, and also the BSc. And this is the most important chapter for the 3-line principles of only this is the Cartesian problem only here. This is without using the vector. So in my next video about the plane, we are also introduce with the help of vector. Okay, so thank you very much everybody. Okay, bye.